Dear students, welcome to the knowledge series. Under the course EC 407 Computer Communication, we are going to discuss in the area of routing protocol. As you are aware that we have seen under the dynamic routing protocol the two segments. One is interior gateway protocol or inter protocols, and another one is exterior gateway protocols, or where we say it as inter and the previous one as intra. So under the intra protocols, we have seen the distance vector protocols, where the protocols work under using an algorithms, and with respect to the link state routing protocol, it works under the algorithms, and followed by there is a inter or a exterior gateway protocols, where it applies the path vector routing protocol. So under this particular segment of a dynamic routing protocol, we will be discussing about a RIP, that is a routing informations protocol. So the routing information protocols it is an inter-domain routing protocol, and also known as interior gateway protocol, which is a intra protocol, and it is used for the autonomous systems. This is a simple protocols, and basically it works under the distance vector routing. That is what I have spoken just now. RIP, as the name indicates, it is based on the hop count as for finding the best possible path from the source to destinations. And in this vector routing protocols, the router interchange the network depending upon the accessibilities, and depending upon the applying the algorithms based on the Bellman-Ford's algorithms. The best possible path is being selected, and thereby they can interchange the set of destinations using the hop address. And the hop count is based on the routers. So you can see here there are different routers are there. So from let us assume that this person want to access the google.com. So from his system, the nearest IP router will be as shown here. From this router, there is a three direction. The three link is moving. One is a route 1 going through a one router, and another route 2 passing through a 3 routers, another route 3 passing through a 3 routers, but having a different hop, say hop 1, 2 hop, and here 3 hops, here 1 hop, that is a 2 hop, here 3 hops, 1, 2 and 3, here it is a 1 hop, 2 hop, 3 hop and 4 hop, like that one. So here you find that here more number of hop is there, here is a lesser number of a hop is there. So the hop count is the number of the routers, that is between the source and the destination of the network. And RIP, it considered a pathway for the best shortest number of the hop. Normally in the case of a RIP, it allows a 15 hops to reach the network, and if the packet does not reach in the 15 hop count, then the destination is considered as unreachable, and a maximum for this 16 routers it can able to employ. So that's why, based on the router and its routing table, it can able to identify the best possible path. Now if assume that this is a 100 kbps route, this is a 256 kbps, say this is a 1000 kbps. So RIP will try to see that which is the minimum hop and which can use a maximum bandwidth utilizations. That hop it will be selecting, even if it is a smaller kbps or a smaller as compared to the other routes. It will always prefer to look for the shortest hop and minimum hop and maximum use of that particular bandwidth. Rather than wasting that particular bandwidth, it will try to account. So that's why we in the RIP performs according to that. Now in the case of RIP, there are three versions is there: RIP v1, RIP v2 and RIP ng. RIP v1 is basically a routing information protocol of a version 1, and it is a class of a routing protocol because it does not send the informations of the subnet mask in the routing update, and it tried to send the broadcast at a 255, 255, 255, 255. You know that broadcast protocol is not assigned to any other nodes, except it is specifically mean for broadcasting purpose. That is completely assigned according. So that is not freely assigned to any other nodes. RIP v2 versions is a class of classless routing protocol. So like it is for IPv6, whereas the previous is for IPv4. So like that. Classless routing protocol because it does not send the information of a subnet mask, but it tried to supports the routing based on the multicast at a 224.0.0.9, and RIP ng is a routing information protocols next generations, and it is extended for the RIPT was actually extended for the IPv6. This is a routing protocol where we are using a hexadecimals like FF02 :9. Basically it is for a IPv6 form of a notations. So that's how it tries to supports the IPv4 or IPv4 and IPv6 protocols. What exactly it does is that it uses the routers and its informations for passing on the data through a appropriate router with a minimum number of hops. The advantage in this case is that basically it is easy to configure. That is one, and every time it does not need an update because a particular sequence is aware. So based on that sequence, the network will try to forms the path, and network will try to pass on the information on that topology. And there is a guarantee that it supports almost all the routers. Now the disadvantage part is that it is based on the hops only, hop count. So if there is a better route available with a better bandwidth, it will not select because that hop is totally defined. It cannot take a zigzag way and try to take a route. So that's the disadvantage part. However, the RIP it tries to solve the problem of the inter gateway protocols for transferring the data based on the distance vector routing. Now we go to the next one is open shortest path first, that is OSPF. So when we try to see the OSPF, it is basically the second type, that is a link state protocol for a inter-domain routing protocols. Intra-domain routing protocols, which is nothing but the interior gateway protocol. And this is also work for autonomous systems. You can see autonomous systems over here. So in the OSPF, the autonomous systems is divided in the form of areas. There are one area, 2 area 1, area 0, like that one. And this is the internet world. So the routing traffic can be handled easy. And each area is formed by the combinations of networks, like host, routers, switches within that autonomous systems. And it is assigned for a unique identifications number. So that is what we see in this particular protocols. And the network resides inside this area and must be connected to each other because of the intra intra protocols or interior gateway protocols. So the router is inside this area of operations, and these routers are periodically updated. So you can see that each router is there inside the area, and there is a router which is on the boundary point. So OSPF, it was developed way back in 1980s by the Internet Engineering Task Force for the OSPF working group. And this, as you can see that from the area of the logical connection of the routers R1, R2, R3, R4 as shown, and this one carry its own IDs like 0, 1, 2, like that one in a respective areas. Now OSPF network contains multiple areas as I have shown to you. And now the area whichever is first, or the main area, that is considered as the backbone area or the area A0, and all other areas A0s, all other areas associated or connected to the A0 area A0, and all the routers within this area must have the same topology or a table link database, so that different routing can be able to carry out. And OSPF, it calculates the best possible path. So for identifying the best possible path, you know that Dijkstra's algorithms we have seen, where the Dijkstra's algorithm is used for solving the link state protocol algorithms. So that is what we try to see. And a router which is there inside this area will have its own topology. So area A1 will be having different topology, area 2 will be having different topology, area A0 will be having a different topology. Like that, a different topology is being followed with respect to the each link. And OSPF, it calculates the different best possible path for the each routers, and depending upon the location of the network topology. Now coming, if you try to see across this one, you can see there are some components like ABR and ASBR. So ABR, it is basically a router, and that router is located on the border point. You can see this area A1 and A0, between that particular point this router is located, on the and more than one OSPF you can able to build up. So ABR router is responsible for summarizing the IP address of each area, and they try to prevent if there is any fault exists. So based on the ABR, it can able to identify. Another is autonomous system boundary router, that is ASBR, and this ASBR is basically a router that interface the one or a more OSPF to the internet world. So it is almost all like ABR. However, the difference is that in the ASBR it is connected to the internet or other devices, and ASBR is normally routed through the router. ASBR actually routes the informations. So in which IP it has to be routed for the internet world to access, or internet world how it has to access the particular end users which is resides on the particular area based on the OSPF system configurations. That is how the ASBR try to support. Now if you look across the advantages and the disadvantages area, this OSPF it run for almost all the routers, since it is based on the open system open standard, and it use the SPF algorithms that is based on the Dijkstra's algorithms. So that is you have to understand because of the link state algorithms, and it provides a loop-free topologies. And SPF stands for Sender Policy Framework, and it provides the update via the link state advertisement or LSAs. Now another thing is that it is a classless protocol and allows for a hierarchical designs. If you are to go for a bigger hierarchical designs and for a router summarizations with respect to this particular protocols, that is OSPF. Now if you look across, the disadvantage part is that because every OSPF is associated to the area, so it requires a more memory to hold the adjacent neighbors informations or a topology or a routing table informations. It requires basically a extra CPU processing and how it has to run the SPF algorithms, and it is complex to configuration and difficult to troubleshoot whenever the problem arises. However, if you look across the futures, it provides scalabilities, because large number of devices can be integrated to the particular areas and the systems or the autonomous systems. And OSPF implements in the two-level hierarchy, that is the area A0 and also the area off to the backbone, because if you look across area 1, it has nearly 65,535 numbers. And now synchronous serial links with if you look across the synchronous serial link, it can have a bandwidth of 1544 kbps. So this is a default bandwidth of a link, each synchronous serial links. OSPF uses the link in terms of a cost as a matrix, and thereby it is the inverse of the bandwidth of the link. So it uses the cost to identify the link, and normally based on the cost of the link, it tries to access the best possible path, so that the OSPF can able to support the intra-domain routing protocols for the end users from the source to destinations in an efficient way, but that which is also an inverse of the bandwidth. So this is what we discuss about the OSPF. Now we go to the next discussion, that is the broader gateway protocols. So when we look across the border gateway protocols, or a BGP, BGP is a inter-domain routing, that is the exterior gateway protocols, and this was developed way back in 1989, and this was implemented basically based on the concept of path vector routing. So BGP work actually between the autonomous systems, that is what we see here in this figure, in an exterior gateway. So if you try to see this one, this is one autonomous system, this is another autonomous systems. So between this one, the BGP tries to work, and it follows the certain policy for the transfer of the packets between these various autonomous systems, and also it configure based on the BGP router. Now here, if you try to see, there is a terminology like a IGP and EGP. You can see EGP is there, IGP is there. IGP is the interior gateway protocols. So a routing protocol operating within this and autonomous systems is considered as a interior gateway protocols like a OSPF or a EIGRD. These are coming under this IGP protocols. If you consider the exterior EGP, it's a routing protocol operating between a different AS. So you know that that particular exterior gateway is basically for the different areas of the autonomous systems. Now if you try to look across here in this figure, R1, R2, R3, R4, R5, R6, they are the protocol, they are the router running within within the respective autonomous systems and communicate with each other. So but to connect the other routers, like if R1 want to communicate with R4, then in that case EGP comes into the picture. Otherwise R1, R2, R3 is communicating with using IGP, and here R4, R5, R6 is communicating using the IGP. But when these autonomous 2 want to communicate with autonomous 1, or autonomous 1 want to communicate with autonomous 2, you want to use a EGP. So if you look across the next down figure, that is a in this one different autonomous is been shown: AS1, AS2, AS3, AS4, AS5 and AS6. So in the BGP, these different ASs or different autonomous system is divided into a different category, like a stub autonomous systems, multi-homed autonomous system, transit of autonomous systems. So that now if you talk about a stub autonomous systems, it has a single connections to any other device, that is it is coming within, and data traffic can be it can able to originate within, and it can able to terminate also within, but it cannot pass any of the data traffic through them. That is known as a stub autonomous system. Suppose if this is a stub, it will not allow the traffic to pass, but it will able to generate and it will able to terminate, but through this it will not able to allow. So that is known as autonomous systems. The multi-homed autonomous systems, if you try to look across, it has a multiple connections with the other systems. It can send the data and to one autonomous or a multiple autonomous systems. It can able to receive, and even it can able to receive from that. But it will also do not allow to pass the traffic through it. So that is a multi-homed autonomous systems. But the word transit, so transit is something like a third party or exterior. So it allows it performs like a multi-homed autonomous system, but except that it allows the third party traffic to pass through it if you are going with a transit of autonomous system. But whereas for the other two, the stub and the multi-homed autonomous system, it will not allow. So the each BGP that we try to see in this case, there are different routers is there, and each router it will try to maintain a routing table, and it keeps the track of the path, just like we have seen the vector methods, and even the distance vector method and the link state protocols. In like that, it tries to identify the best possible path or shortest path. Now to understand these BGP operations, let's see these figures and consider a path. Assume that this is AS4 want to communicate with AS6, and if this AS4 want to communicate with AS6, assume that this is A, B, C, D, E, F. So we consider AS4 as D and this as F. So it will take a path D, E, F. This path it can take so that it will be the shortest path to reach. Now assume that a path is generating from A. So if a path is generating from A, it will not allow to pass through D because of the homed conditions, as well as stub conditions, as well as multi-homed condition. It will not allow. So under that particular situations, where the path which is generated through A, it will be discarded. So let us try to see the path from D. Now if you try to see the score, like how the each path is being scoring based on the shortest length, that is what we say the cost of the link, how it is going to maintain. Now here we take situations like this particular link is having a issues. So normally this is the best path for the D, that is a EF, and assume that because of some problem this D has got crash, or E is, this node has got crash, or this router has got crash, or this particular BGP has got crashed. So if this BGP has got crash or the router has got crash, then all the link corresponding to this one will not be operative. So this A can go through this way, one, or this can take it this way. So or A will try it, this will go like this way. So these are the possible paths. So assume that the path we are designed is nothing but this BCF, ADBCF, or DA BCF. Of course DAD we cannot take if the D is not allowed to path. So the route BCF is selected, and if the BCF is selected, and then the through D this particular path is being generated from here, the source, it will take this path. So this is the only path it is being selected, that is the new shortest path, because of the one link or a one router's failure. So this is what we see in the border gateway. So if this is a border gateway, the border gateway is also try to see that if one border gateway fails, it tries to look the next possible path for routing the informations. What is the advantage? If you look across the advantage, the routing table in this case is stable. It does not react to the issues of the particular autonomous systems. So there is a less chance of a table changing, because this router is maintaining. If there is an issue is here, the router will be still having a informations. So that is one thing we have to look into it. And there are number of attributes in this case which try to ensure that the routing is effectively operating in the case of that autonomous systems. And if you try to see across the disadvantage, if you look across the disadvantage part, it is a complex protocols, because it has to manage the autonomous systems, it has to manage the routers. So everything need to be tuned, and it has to perform correctly. So BGP routing algorithm normally has nearly 14 to 15 steps to determine the best path. So if there is instability in the autonomous systems, so this router may flap, or may able to ignore. So that is what we see in this case of a border gateway protocol, or a BGP. Now we go to the next discussions, that is a multi-portal labels switching, that is a MPLS. Now MPLS basically it's a technology used in a computer network, that is to regulate the network data traffic, and it try to see that the data packet can able to send or able to flow from a node to node at a much faster rates. So in this type of a network, the data traffic technique that carries the data from one network to another network. It is basically on the using a short distance or a short path. It is what we try to see, because here the short path mechanism is being applied for selecting. And because of the complexity and of the network, the routers is accordingly try to maintain the routes. So you can see a customer is there at the one point, different customer, and the other customer at the other point it tries to communicate. And in this case you can try to see that it is the like a gateway, that is a level edge router which try to route from the different network, different area of network to the MPLS, and thereby the MPLS route that data to the end user customer. So in a conventional router IP protocols, where we have seen the data packet arrives and the router makes the independent forwarding decisions, that particular process is a complex. So to solve that one, this MPLS, that is a multiportal, see, this is not multiportal, that is multi-protocol. So that is for a correction, please note. This is a multi-protocol label switching. So multi-protocol label switching try to provide these solutions. Actually in MPLS, what it will try to carries the particular packet, and it applies whether it is a packet switching or a circuit switching, and thereby it use the your label switching routers. You can see the LSP routers or the LSP path. It is being selected through the LSP, that is a label edge router, label edge label switching router, and label switching path. It tries to form the connectivity from the two end users. And this particular architecture is seamlessly used for the IP IP protocols or asynchronous transfer modes, that ATM or Ethernet areas. This particular MPLS architecture is being employed. Another thing is that if you try to look across the traditional OS models like Ethernet, when we try to take Internet protocols, so Ethernet operates under the layer 2, and this is used for the network connectivities in a direct connectivity modes in the wide area network. And here when we are using a layer 3, that is a Internet protocol network layer, and this particular IP is being passed through this MPLS, and MPLS try to do a interface between these layer 2 and the layer 3, and thereby the data packet can able to transfer from the application layer, whichever it is coming, to the from a one nodal point to the destination nodal point for the transfer through the Ethernet networking systems. So this uses a simple topologies, that is a packet for forwarding topologies for data transfers. So if you try to see across the LSP, it is having a unidirectional tunnel in the case of MPLS routers. So in this particular case, the real efficiency is based on the IP and the router. So you can able to get maximum throughput in this case, because the MPLS automatically defines the path, and thereby it can able to deliver the maximum in a maximize output way, or you can say that the throughput will be more. So that's why if you look across the advantage, MPLS is having a scalability. So you can add more number of LSR systems in this case. So that's why it will improve the bandwidth utilizations and avoid the network congestions. So the MPLS is itself is a separate network architecture, and it has a security because it does not need a encryption because of the virtual private network. So that's a security it can be able to provide, and it is not vulnerable due to the denial of service attack. Denial of service attack, as you know, like you send an email and you say that you are not send an email. So like that of vulnerable attack is not possible because it is purely IP based network. But the disadvantage part is that it is costly because this service the subscriber, they need to purchase, and it is more expensive. So a bigger companies can it tries to go with this one. However, because if a bigger company go with MPLS and that covers the global coverage, then it needed a partnership with various companies, so that then only the network build-up can able to make. Otherwise, it is costly. On the other hand, MPLS is also cannot go for a much scalable, because nowadays the every users, they are using directly like a Google Cloud or any other form of a cloud networking. So basically, because of the cloud accessibility, MPLS find it difficult for the further expansion and try to contribute for its technology to survive. So that is what we see in the case of a multiportal label switching network. So with this we come to the conclusions with respect to the discussions on the area of different routing protocols, where we have seen the routing information protocols, RIP, where the routers is playing a major roles using a distance vector routing protocols or algorithms. Next, we discuss the open shortest path first, where the link state protocols is being used, and both the RIP and OSPF both are coming under intra systems, protocols systems. Then followed by, we have discussed about BGP, that is a broader gateway protocol, which is inter or exterior gateway protocols. And finally we discuss a multi-protocol label switchings, where in the protocols label switching, we have seen that how the independent network architecture can able to handle the large number of database, a large number of the area networks or the terminals to pass through their own architectures, where the several routers can be configured in a seamlessly manner, so that the network can able to deliver a maximum efficiency and maximum throughput and scalability conditions it can able to perform. With this we come to the conclusions.